So welcome everyone to the Space Awareness. No? Can you hear me? Can you hear me now? Can I talk now? Yes? Okay. Sorry about that. Okay, so welcome everybody to the Space Awareness webinar, Space Life Science Challenges, Integrating Art with Science and Engineering to Engage and Innovate. My name is Marina Jimenez, I work for European Schoolnet, and I will be moderating this session today. Our presenter for this session is Dr. Jancy McPhee, Executive Director of SciArt Exchange. Previously, she was a cellular and molecular neuroscience researcher for 17 years before joining the University Space Research Association to manage various aspects of NASA's domestic and international space life science research programs. In today's webinar, you will learn what are the challenges of long-distance and long-term space flights for human space travelers. Our speaker will discuss how integrating art with space science and engineering can promote the engagement, innovation, and collaboration required to solve space challenges. The presentation will last about 45 minutes, and after that we will dedicate about 15 minutes to your questions. In case you encounter any technical problem during the presentation, please write to my colleague Adina in the chat and she will support you through it. You can find the chat tab on the right side of the screen. Again, at the end of the session, we will have some time to address questions to our presenters, so please share them on the comments in the chat. Also, I remind you that at the end of the session, I will be sharing with you a survey so you can rate this webinar. And now I leave the floor to Jancy, and welcome and thank you for being here.
Hello everybody, it's a pleasure to speak with you today, and I'm looking forward to any questions that you might have at the end or in the middle if that works. So let me just start by telling you a little bit about myself. So I was that young person who liked everything and was interested in everything and wasn't quite sure what direction I should go in and what I should be when I grow up. And I was really lucky to have excellent teachers in both the sciences and also the humanities. And I bet there's a bunch of excellent teachers online right now, and we are all very, very grateful for the time that you're putting in to learn about new topics and get new ideas for your students. So I also had a lot of my personal hobbies were in music and the performing arts. So when I eventually had to decide what to be when I grew up, I did decide to become a scientist. And in case some of you are not familiar, a neuroscientist is basically studying the nerves of the brain and the body, and thus exploring the science of human thoughts, emotions, creativity, and movement. So that is what I was interested in, and my studies took me way down to the level of cells and molecules. But when I came to work for NASA, I moved back out to study the big picture, and I'm in the middle of this picture here, and I was responsible for thinking about strategies and how to organize international collaborations so that we could solve a lot of the challenges that we have for the human body in space on long duration and long distance space missions. And I learned a lot during both my experience as a scientist and my experience as a coordinator of international space life sciences research programs. And I learned that communicating to our peers, but also to public and students, was an incredibly important thing that sometimes we don't pay enough attention to, and because those people are going to be our future colleagues, our workforce, our political and financial supporters. And I had experienced a lot of lack of good communication. And I was even surprised, even within our own team of scientists and engineers and medical doctors, we often could not talk to each other in a way that each other could really understand. So communication was important. I also think in order to solve future challenges, we need new ideas, so we need innovation, and I am also very much the teaming queen. So I really want as many different kinds of people working together to solve problems. And so that is why I started the nonprofit, SciArt Exchange, and we will talk a little bit about what we do and what's at the basis of our work in the second half of our talk today. But basically, first, I'd like to talk to you a little bit about what the challenges of space life sciences are as we move further and further away from the Earth into space and carry on new missions. Then tell you a little bit about what I've learned about the value of integrating art with science, technology, engineering, and math topics or education. And then tell you a little bit about what our nonprofit is doing using activities that integrate science and engineering with the arts, and hopefully give you some ideas for things that you might be able to do for your own students. So first, let's get and talk about those challenges. As you know, here's a picture of Mars. So we're going to focus kind of their discussion today on the challenges of getting humans to Mars. And I presume that most of you are aware that we already have a space station that is circling the Earth. Hopefully that's true. If not, then that's the first thing we're all learning today. So that's excellent. But it is a whole lot further to get to Mars, and there are tremendous challenges, and we'll start talking about those. But first, why would we want to go to Mars? I'm curious, does anyone out there want to go to Mars? And if so, please, drop a little note in the chat. I'm curious to know how many people would want themselves to go to Mars. I think it's a very interesting question, especially if I ask it now and then ask it again later. And we'll see after you see what the challenges are if you still want to go. So one of the main reasons we are so interested in going to Mars is because we believe that we may discover life there. And there's good reasons why. There is water on Mars, and there's some initial evidence that there may have been life. It would also be reasonable because we believe that Mars used to be a lot warmer. Right now it's pretty cold, and if there's any life on it at the moment, it's going to be very far below the surface of the planet. But humans are very interested in understanding whether they are alone in the universe as life. The problem with Mars is that it's really far away. And I don't know if you've ever thought about just how far away it is, but it's almost 58 million kilometers away. So in order to get there, it's going to take, with our current technology, it's going to take 2.5 years to get there, stay there, and come back. The journey there alone would take about 6 months. So it's not going to be an easy trip. There are other things about Mars that make it a little bit difficult to work there and live there. One is that there's less gravity there. There's about 0.38 times the amount of gravity. There is less atmosphere, and the kind of atmosphere is different. It's very high in carbon dioxide, whereas ours is high in nitrogen, and it's a lot colder. So that makes the environment quite different, and that's just the top level issues. Also, when we get there after spending 6 months in flight, we can't just lie back and kind of rest. We're going to have to do a whole lot when we get there. We're going to have to set up a place to live. We're going to have to unpack everything we brought to support ourselves, at least in the beginning. And we're going to have to start setting up all the science equipment and engineering equipment that we'll be using to get there. So we're going to have to be quite busy when we arrive. So we need to be in good shape during the trip, as well as during the trip travel to Mars, as well as in good shape while we're on Mars. So that's why when we think about preparing to go so far away on such a long trip, we actually think about doing it in multiple steps on the way. So here's a representation of NASA's current view of what they think they might do in steps to get to Mars. So you can see with my mouse here that we are currently in space doing activities very close to the Earth. So we have the International Space Station and lots of satellites and telescopes and we've done tremendous research and science there. And one of our next steps will be to consider going back to the moon, either around the moon or on the surface. And there are lots of different space agencies and commercial companies interested in that. Yes, it is a very nice poster, isn't it? I wish I had made it, but I didn't. And or we may also want to explore asteroids, possibly as a way to see if there's anything of value in an asteroid, but probably most importantly to help us not have to live through an asteroid impact on the Earth, which, as you know, led to the extinction of the dinosaurs. And also, then we can start thinking about the longer journey to Mars, to the moons around Mars, the atmosphere around Mars, and to the surface of Mars. So there are many steps, and part of the challenges are to think about which steps will we do, and how will we do the technology to allow us to do that, and getting back on topic, how will we overcome the challenges to the human body? So I don't know how many of you know about what happens to the human body in space, so I'm just going to give you an overview. So let's think about first what happens because of reduced gravity. So if you're flying in space, there's very little gravity, and if you get to Mars, there's less gravity on the Earth. So these effects will happen a lot in transit on the spaceship, but there, to a certain extent, some of it may also happen on the surface of Mars. So the first thing is that without gravity, all of the fluids in your body are shifted headwards. So that leads to a lot of changes in the beginning, but also long term. The first is that when you first get there, your head feels very stuffy. The good news is that your face gets really full and you look very young, and that's lovely. But eventually your body gets rid of some of the extra fluid, and that actually leads to some changes in the heart. So that can be some issues. Also, without gravity, you're not bearing weight on your muscles and bones like we do every day as we walk. And since we're not putting a lot of stress on the muscles and bones, the muscles and the bones get smaller and weaker. And that's okay if you're going to stay where there's less gravity, but if you transition or move to a different kind of gravity environment, a heavier one, then your weaker muscles and bones may not be able to help you do what you need to do, and you could actually break bones. In addition, as you move from one gravity environment to another, the signals in your inner ear that actually sense gravity notice that there's a change, and it can be very confusing for your body. You can feel very sick to your stomach for a while, you can be dizzy, you can have balance issues. So gravity is a very important difference in various space environments that have to be considered when we think about the challenge of going further in space. In addition, there are even some changes in the eye, and some of those changes have been lasting long term. There have been some astronauts who have spent a long time on the International Space Station who have come back and their vision has not quite recovered, and they cannot see things up close very well. So that's a problem that we need to understand, because we don't want to cause any lasting harm to our astronauts. So all of these things alone can be significant challenges for when you arrive, let's say, to Mars, where there is some significant gravity. We don't want to arrive in really bad shape. And that's not to say that these cosmonauts are in really bad shape, but when you first come back to Earth, you are a little bit weaker. And they have worked hard not to get too out of shape. And I'm going to tell you a little bit about what astronauts and cosmonauts do now to stay in good shape. Exercise. And I don't mean a little bit of exercise, I mean hours and hours of exercise while they're in space. And they have to have special equipment where they're strapped down so that they have huge rubber bands that are keeping them connected with their equipment. And they work out very hard, both doing cardiovascular, running and bicycling exercises, as well as weight-bearing exercises to keep their muscles and bone and heart in good shape. There has also been a discussion of how we change the spacecraft to actually mimic load on our muscles and bones and our fluid systems. And one idea is to create essentially an artificial gravity while we're in a spacecraft. And there are two ways to do that, and this is one of the things that I studied while I was at NASA. One is to put on board a very short arm centrifuge. So a centrifuge is something that spins like this, creating forces that move from the center out. And to put people in there for a certain length of time each day so that they load their lower body, their muscles and their bones, for at least a little while every day, even if they're in a low gravity environment. They could even exercise while they're spinning on the short arm centrifuge. Now there are a lot of problems and a lot of issues and a lot of research that needs to be done, because as you can imagine, spending a little while on a centrifuge may make you a little bit dizzy. So there are a lot of challenges to overcome. Another artificial gravity idea is to make a very long spacecraft and spin it very slowly, like in the picture to the right and the bottom. So that's a long radius centrifuge. And to just live in that environment all the time so that there's a sort of an artificial gravity while you're on your trip to wherever you're going. So those are some other ideas for solutions to the problems that we've been talking about so far, besides exercise. Another very important way to deal with the challenges that we've discussed so far is, what do you eat? So food is extremely important, and it's also very challenging. So you have to bring all of your food with you on the trip to wherever you're going, and at least some of the food initially while you arrive. So you have to be able to package the food so that it will last for, let's say, 3 years. You have to create food that is interesting, because although we may not like to admit it, we all know that food is also fun and interesting. And we also need to be sure that we have all the right nutrients in the food. So another thing that I studied while I was at NASA was, what is really the best balanced diet for someone traveling in space for a very long time. And the bottom line really is that what our grandmothers have been telling us is true, that we need to eat all of our fruits and vegetables, because there are so many small nutrients besides carbohydrates and proteins and fats that are important to keeping the human body safe, especially in a stressful environment. So food is very, very challenging and very, very important, and needs to be well considered in thinking about getting us to a place like Mars. And ultimately, the next challenge is, we will want to be able to grow food wherever we go. And this is a picture from the movie The Martian, and it's going very well in this picture, but there's still a lot that needs to be worked out before we can get to the point where we can grow literally a forest of food on someplace other than the Earth or on a spacecraft. So we've talked about muscles and bones and our balance systems and our heart system, but that's not the end of the challenges. We also have other kinds of challenges. So here's a picture of an astronaut sleeping in space. Being comfortable in space is actually a challenge because you are not going to be able to lie down on a surface. You have to be strapped down. And so everything floats except where you're strapped down. So being comfortable while sleeping is very important. But that's not the only part that's important. The patterns of light and your own biological rhythms are changed in space. So Mars, the sunset and the color of the light is different than it is on the Earth. And the day is a little bit longer. And believe it or not, those things can really change the rhythm of the human body. You put on top of that the fact that everyone is working very, very hard and maybe not sleeping, at least in the beginning, quite as well as they expected. All of this lack of sleep could lead to changes in the ability of the astronaut to be able to do their job properly. So it's very important for us to consider not just the gravity of the space environment, but also the lights and the rhythms. On top of that, how many people think that they could spend time in an extremely small place with 6 people for 3 years and not have some arguments? So this cartoon makes fun of it, but the truth is that there are challenges to keep a team of people under a stressful condition in a small space for a long time, getting along well and able to do their jobs well. And there's a lot of work in that area. On the left here, you'll see that there's even some work to try to look at the faces of astronauts and figure out if they're not doing well, even if they won't admit it to themselves or their team members, because you want to get problems taken care of before they become serious problems. There is also a lot of work on how to help astronauts' bodies to be in a good rhythm, to make sure that they get enough sleep, to make sure that they are not overworked during the day, that they get some time to relax, and also a lot of work on how to keep people happy working with each other so they will cooperate and communicate well. And some of those things that they're doing to keep the people happy include sending them, while here on Earth, on stressful trips, essentially, where they have to work together. And so they learn to work together as a team. They learn about the things that work with each other. They learn about taking turns being the leader versus the follower. And they get to know each other very well. As you can imagine, astronauts are very smart, and many of them are used to being leaders. So it is an unusual thing sometimes for them to have to take turns being leaders. There's also a lot of work to communicate with the ground and also provide fun things on the trip that the astronauts will like. I saw in the chat somebody brought up radiation. Radiation is absolutely something important that we will have to deal with. And you probably are all thinking about cancer risks, but there are also problems if there is a very short and heavy radiation exposure. There can be sickness very quickly after let's say a solar event, and the risk can be very high on some of these long duration missions. Plus, longer term, there can also be effects genetically and also on the nervous system. So radiation needs to be an important challenge that we work on. And to a certain extent, what we do with our habitats, our spacecraft, and our spacesuits will help to cut back on radiation exposure. But honestly, at the moment, the best solution, for instance, is not to go outside when you know there's a heavy radiation event occurring and to take shelter in a place that is set up to minimize radiation exposure. Spacesuits themselves are challenges. They're very heavy. They're very hard to walk in. Sometimes they're hard to take on and off. Sometimes the cooling is a problem. So there's a lot of challenge left in spacesuits, and they're working very hard on that. And then the last topic, and then we're going to move on to the next part of the talk, is let's talk about what will we do to provide medical care. So these trips can be 2.5 years long, and they're going to be very far away. It may take a long time for them to send a message from, let's say, Mars to the Earth. It will take several minutes. That makes monitoring the health of someone and diagnosing more challenging. It's a very long distance activity. So there's going to have to be a lot of capability right there on the spacecraft or on the surface of Mars. And this is imagination from the television show and movies series Star Trek. We are not nearly this advanced in our ability to treat, and we're going to have to be able to have drugs that can last for years without going bad. We'll need to have people able to do potentially surgeries. And based on just our best estimate for a trip that takes 2.5 to 3 years, there will probably be one person who needs an emergency room. So we have to take our medical care challenge very seriously. So we have talked a little bit about the challenges of space, sending the humans to space, and this is related to a lot of the work that I did at NASA, and that's just kind of an overview, the challenges created by the space environment itself, the challenges of the spacecrafts and the habitats, being in closed environments, having a lot of work to do, needing to provide all of your food. And we did not quite talk about the challenges of launching and landing, but those are also an issue. But we did talk about how being far away makes a lot of challenges, and our inherent body rhythms are also a challenge. So what are we going to do to try to help solve some of those challenges? So you'll have remembered from the discussion that I made when I told you a little bit about myself. I am very interested in helping us to solve challenges by thinking about better engaging people in understanding and being educated about space. So it's very, very important that if we're talking just about education, and that's the way I'm going to talk about this mostly because I believe that most of you are educators, then it's very important that we motivate students to want to learn and become a part of the future of space and have a role in solving space challenges. So it's important that we tell them not just about what the challenges are, but why those challenges are important, so that they will care and be motivated to learn more. So that's why we focus so much on engaging and making people care. And the other focus we have is on bringing new ideas into the science and technology community. So you're going to start to see a little bit of art from our activities. So innovation is very important, and I think it's important to train our students to not only know facts, but also to be able to do interesting and creative things with their facts. And And at the basis of innovation is creativity. So it's very important to be training the imagination of our students as well as interesting them and presenting them with science and technology information. And as a neuroscientist, I like to think a little bit about what do we see in really creative people, and therefore what can we do to make more creative students. So the first thing is to realize that it is definitely important to teach our students the science and the engineering and all of the maths processes that we're all working so hard to teach. But it is also important to think about making sure that they also have a very broad education on top of that. Because it turns out that creative people are the people who, in their brains, take a lot of different kinds of ideas and knowledge and connect them in new ways. That's what it means to be creative in a physical way. So you have to have a broad experience of information so that you can be the one who is imaginative and can lead to innovation. You also have to allow yourself to be open to new ideas. And I'm not so young, so I was trained in a very traditional way where we were focused on specific subjects and we did not connect our subjects very well to other kinds of topics. So I am really trying to encourage people to train their imagination as well as their other skills so that they are better communicators and more creative. And also, creative people are very motivated. So again, we need to tell them why they should care. We need to tell them that they have a role in the future. So this is how you encourage people to be creative. And even as you're collaborating, you need to have a language that everyone can use and a group of people that is open to thinking differently. So our nonprofit, SciArt Exchange, thinks that it's very helpful to bring the arts into the science and engineering community that is working together to solve these space challenges that we just finished discussing. And there is a lot of evidence that art is an excellent tool for communicating about space and science and technology. It's also a great way to motivate students to want to learn more. They are actually performing better on their exams in science and technology, and they're able to use their information in more creative ways. There's also a lot of evidence that we see from the broader public, not just our students, that we can get the public very interested when we use art as our symbols and our way of talking about important space and science and technology issues. Also, art is very inspiring. And I don't know how many of you watch Star Trek, but I grew up with the original Star Trek, and I was inspired by watching that show to become interested and want to dream about the future of space and to be a part of it. So I would like to please, hopefully I have convinced you that we have a lot of challenges in space, that we need to educate our students and our public, and that perhaps there's some value in bringing the arts in as a technique to do that. So the last thing I want to do is tell you a little bit about what we're doing to integrate science and engineering with the arts. So our nonprofit has a program called the Humans in Space Art Program, and it's an international project. It has a very simple strategy. That is, no matter who we want to touch, whether it's children, young adults, or professional artists, we want to invite them to learn something about an important topic about space and science and engineering, and give them an opportunity to tell us their vision of the future and to give them any way to communicate their ideas. So they can write us a story, they can give us a short film, they can paint us a picture or make a sculpture, they can write us a symphony or a hip hop or a pop song, a folk song, whatever type of format they want to use to communicate is acceptable to us, and we bring it into these large international contests, and then we will determine the winners, but then we do the second thing, which is what makes us a little bit more unusual, is we use all of that artwork in as many displays and performances online, locally around the world, and in space. So now all the artwork that we've collected is now inspiring and engaging all the listeners and the viewers around the world in thinking about space, how it will affect their lives, and possibly how they can also contribute to the future. So we touch the lives of the artist participants, but we also touch the lives of everyone viewing the art. And that, we hope, is a good way to get more people interested and educated about space and all the science and technology that has to develop to handle the space challenges. So since I believe most of you are educating children, I was going to show you a little examples from our children's contest. We have, up until now, had thousands of artworks from 52 countries, and we are able to use that artwork in displays and performances. So we've had more than 100 in many locations around the world, some on the International Space Station, and we have even bounced artwork off the moon. So we have been very fortunate to use this artwork to inspire others. These are just some images of some of the art that we've shown in space. And we've also been able to bring the top children together to meet each other, to begin that collaboration across countries. And they still keep in touch on social media like Facebook and Twitter, and I see even 5 years later they wish each other happy birthdays, and this is the beginning of collaborations across our world. But they also get to meet current scientists and engineers to talk about their vision of the future. So now these children are preparing themselves to be our future workforce, our future voters, and they feel that they will be a part of the future of space. I don't think I have time, but we have had beautiful multimedia live performances both in Houston and in Cologne, Germany, with music composed by 15 and 16-year-olds, and live poetry readings and dance interpretations and printed artwork. It's been really wonderful. There are opportunities for all of you. So we are working hard to set up new contests under the nonprofit, which is still fairly young. And I am hoping that after this webinar, you will be interested in helping people to participate in our international contests, to possibly be judges, and if appropriate and you're interested, we could also talk about using some of the artwork in your local community to inspire your local community. You could put up a display or perhaps do a performance. It is completely up to you. And I am also available for doing training if that is important for your community. We do have something that is coming very soon. It's for college and early career students. It's a film and poster contest about Mars. It's called Project Mars, and it's in collaboration with NASA. So that should actually be opening in just a couple of weeks. And although it's not for children, If it is appropriate in your classrooms, you could still encourage your students to create films or film posters and then submit them to this contest. I also hope to have a children's contest opening in the next year, at least for ages 10 to 14, maybe up to 18. And so I hope that you will stay in communication. And I will show you how to sign up on our mailing list at the end. But the last part, in the last few minutes, is I wanted to suggest that you can engage your students in these international contests that we hold. But even if we don't have one that's open, you can have your own little mini classroom contests. So I would encourage you to use art as often as you can in your science and technology classes to, encourage students to take their ideas and capture them in images, to practice selling their ideas, because they have to, when they grow up, they have to learn to be able to communicate and convince people of the value of their ideas, and even to practice maybe the equivalent of making little, they could make a poem about their science and technology. You could even have classroom contests, but even just the act of having to think differently about their science and engineering topics and communicate it and perhaps work together in teams is a very good exercise. And using these techniques in your classroom, you can talk about a lot of different things. You can talk about why do we explore, our needs to explore, as is shown here in the artwork on the screen. You can again talk about why would we explore in space, why would we develop all the science and technology. Perhaps it's because of our interest in finding life elsewhere, or it's because of our interest in taking better care of our own planet and possibly needing to explore other planets to keep the human race alive and well. You can also talk about what will be our strategy to go further in space. Will we go to an asteroid, to the moon, to Mars? You can also talk about, will we be doing it robotically in spacecrafts and with rovers, or will we be physically on planets and moons in habitats and colonies? And we should also talk about, what are we going to do when we get there? What's the science we're going to do? What's the research? Are we going to also be opening commercial organizations? So the art is a very good tool for both the learning and the imagination training and the communication about space. And space is a great tool to talk about many different topics of science and engineering, including medicine, energy, and many different topics of science and technology. So we are on the last slide, and I will be almost exactly on time, I hope. I would love to please encourage all of you to get on our mailing list, which is on our website, so that you will know when we have international contests. I also am very interested in hearing from any of you. If you have some ideas or you want to be involved, there's an email address if you would like to contact me. And I do hope that through this webinar you have learned something about the challenges of humans traveling longer and further in space, and a couple of ideas on how we hope to help bring people around the world to think creatively and solve those challenges, and that perhaps it will give you some ideas for both topics and ways that you can discuss these things with your students. And again, I'd be happy to talk with anyone, and I think I'll stop there, and if there are any questions, please let me know. Thank you, everyone.
So, thank you, Jancy, for your presentation. It was very interesting. Before we go to the questions, I'd just like to remind everyone that Adina is now going to post the survey, the evaluation survey. So for the participants, if you can fill it in, that would be great. Regarding the questions, the first one I want to mention that I've seen while you were talking, it's Maria is actually asking for the links for any of the contents that you have mentioned. Otherwise, you can send it to me and Adina, and we will share it with the participants once we send your presentation.
Okay, so much of
Okay.
our material is available through our nonprofit website. Uh, and that will connect you to galleries of artwork from our past Humans in Space Art contests, but all future information will be on the SciArt Exchange website. So
Okay.
please go there, and then that will help connect you to the past Humans in Space artwork. And I do want to apologize, as a new nonprofit, our website needs a lot of work. So if something doesn't make sense, please feel free to contact us through the website or to use the email that I have indicated on the last slide.
Okay. So thank you for sharing the URL. So going back to the questions, about like 10 minutes ago, Ebe, she posted something. She asked, according to you, which is the most important difficulty for life in space out of all the ones that you have mentioned?
So that's a very interesting question. I don't really think that I can choose one, but I can tell you that as a neuroscientist, I think that the teamwork is going to be very challenging. And that's because people are extremely complicated and they react differently during stress. And I think it's going to be a very, very important challenge. And I've been in a lot of meetings where there have been many, many questions, such as should we send all men? Should we send all women? Should we send 6 people who don't know each other? Should we send just couples? There are, it's a very, very long trip. So it's very, very interesting, but there has been a lot of progress made on how to teach people to respect each other and get along. I also think that radiation is a very serious challenge, but I've heard a lot of ideas about how we could provide some really good shielding to help us to survive radiation events, not just the background, but when there's very large solar flares. So I think that we're going to be able to overcome that. I'm optimistic that we'll be able to overcome all of the challenges, but I think it's important to realize that the risks there are a lot of them, and some of them are very hard. So now I get to ask, who still wants to go to Mars? So while you're answering that, is there another question?
I've just seen another one from Ahmed. He asks, how can art affect space exploration?
Okay, so the easiest way for us to talk to science and engineering communities that everyone understands right away is that art is a wonderful tool to talk about science and engineering. Whether you're trying to get students interested in learning more and becoming a part of the future workforce, it's excellent. It's also an excellent tool to get the general public interested so that they will vote to support us or to continue to allow funding to go into space and science and technology. I do really think, though, that our future workforce needs to be trained to be creative. And I think that art and science are both, and engineering, are all creative, but they they come to problems with different ways of thinking. So I think that we train ourselves and our teams to be better at solving problems if we train everyone on the team to think in many different ways. So I think art is a good training tool for science and engineering. I also think that, and this is the hard part for people to understand in the science and engineering community, I really think that we will get different kinds of solutions if we bring larger groups of people who who try to answer questions differently together and give them the tools to be able to talk to each other. So to bring an artist into a group trying to solve a science and technology question would ultimately be a great idea.
Well, thank you for this answer. There's another question from Aneli, and she says, how long, I'm reading literally, how long do you think it would take to really be able to solve these challenges and start exploring Mars?
So, first of all, I'm not sure I can answer that question, but I know that there's a lot of different opinions. Some of you may realize that we have some commercial organizations that think that they can physically get people to Mars in just a few years. My concern is that I think that we want to be sure that we have a lot of these challenges solved to the best of our ability before we go, because I'd also like to see them come back. So I think that in reality it's going to take several decades before people can go and spend a long time and also come back. But it's going to depend a little bit on how well we cooperate to solve these challenges. If we can really cooperate, I think we will make the time shorter.
Okay, I guess that's a fair answer. While we wait, I think there's some people typing, so let's give it a bit more time and see if there's any other question. I asked on the meantime again if anybody still wanted to go to Mars on the chat, and I'm not sure anyone is really convinced.
There are hundreds of thousands of people who have signed up to go to Mars one way. So there are many people around the world who are willing to do that, even if they're not even going to try to come back. So it is very interesting. And I think that besides thinking about the life sciences, I think that we could talk for years and get a lot of people interested in working together to solve these problems.
Well, I don't see any other question in the chat so far. Apart from very good feedback from everyone. Everyone really liked the presentation. Then just a reminder for everyone that the recording will be available on the Space Awareness Career Hub. I'll just wait a couple more minutes because we have some time, and otherwise we can close if that's okay.
Is anybody interested in possibly bringing some of the art that we have to their local environments? If so, please contact me, because we are curating thousands of artworks if anyone is interested. Also, please do consider participating yourselves or encouraging your students to participate in our international contests. And thank you for your time, everyone. I really appreciate it.
I think I saw someone previously on the chat, Slavika maybe, she was interested, or he was interested in participating in some of the initiatives that you were mentioning.
Wonderful. Please just get in touch.
And for everyone, in case you don't see, her email is right in the middle of the screen. Okay, we'll see. Slavika, she will actually contact you. I can see it in the chat now. And again, a lot of good feedback from everyone. If there's not any more questions, I think we will be closing already. Thank you everyone for participating. As I've said, you can find the recording, we'll send it soon. And thank you, Jancy, for taking the time to make this great presentation. We really appreciate it. And to everyone, we'll see you next time. Thanks again.
Thank you. Bye-bye.